Welcome to Embedded Edge, a podcast show hosted by Maurizio Di Paolo Emilio that brings life to some of the stories on embedded systems technologies and products featured on embedded.com and through other Aspencore media publications. In this show, you'll hear both engineers and executives discuss news, challenges and opportunities for embedded systems design in markets such as automotive, industrial, aerospace and consumer. Here is your host, Editor-in-Chief of Power Electronics News and Embedded.com, Maurizio Di Paolo Emilio.
Hello everyone and welcome to another episode of Embedded Edge, where we explore the technologies shaping the future of embedded systems. Today's episode is brought to you by our sponsor, Texas Instruments, TI, a leader in advancing semiconductor innovation across automotive, industrial and IoT applications. In this podcast, we will talk about how TI is leading the next wave of change at the edge by combining AI, smart sensing, and wireless connectivity to improve performance, safety, and efficiency. We will look at how connectivity and embedded AI are coming together to make systems smarter and more responsive across industries. For example, machine learning is changing how cars can be accessed and how the environment can be sensed. Tire pressure monitoring, TPMS, and battery management systems, BMS, are also becoming intelligent networks that can make decisions. Today, we have Peder Rand as a guest. He is the Director of Ecosystem Partnerships, Standard Alliances, and Technology Strategy for Connectivity at Texas Instruments. Peder will talk about how the balance between cloud and edge processing is changing, what problems developers have when they try to add AI-driven intelligence to the edge, and how TI's partnerships and standards efforts are making it possible for connected solutions to be seamless, safe, and scalable. Let's talk with Peder. Hi, Peder. Thanks a lot for being here. How is it going?
Thanks, Maurizio. It's going great. Very happy to be inside today, recording this podcast instead of being outside. It's really raining and cold here. First days of autumn in Oslo, Norway, where I sit with my team, and very happy to be talking to you.
You are located in Norway, Oslo.
Yes.
Good, nice place. So today, we will try to understand more about AI-driven connectivity and the related technologies, as I already mentioned at the beginning. So before starting with the topics and questions that I have prepared, so tell us more about you. Please introduce yourself. Give us a bit about your background.
So I work here in TI in Norway. I am in the connectivity business, so anything wireless. I drive the standards strategy, our ecosystems that we participate in, as well as our general technology strategy, of which both all wireless technologies, but now also edge AI is a very important part. Been in this industry with doing connectivity for 20 years, and I've had, I think, I can tick off almost all the different roles, and very excited about everything that's new in our industry and that can drive the technology forward into new applications.
Good, thank you. So let's start. Let me share my first topic. So we will talk about connectivity. So as AI moves into connectivity solutions, so the balance between the cloud, the edge is shifting. So how do you see this balance evolving? So, and in particular, specifically, how can edge AI help with issues like power consumption, just to mention, but also security, latency, privacy. So let's analyze what are the biggest bottlenecks that you see when moving intelligence closer to the edge.
I think the first touches we had with AI in the connectivity part of the industry was when the remote control started having voice recognition, 7 years ago. And the enabling factor at that point was really the connectivity. The connectivity allowed you to transmit the data to the cloud for processing, and you could figure out what people were trying to say. Then that was enhanced with some wake word detection locally, and so all that that was the beginning of a transition that I think we're still seeing, where we're moving more and more from the cloud processing to edge processing. A couple of drivers, right? One is just because we now can the processing at the edge, and especially with the new accelerators, dedicated accelerators for AI, convolutional neural network processing, for example, that's coming into the devices themselves, helps drive down the latency, the power consumption of those implementation on the edge. So I think that's still shifting. So as you mentioned, some of the kind of critical parameters that are driving and motivating that shift is, mentioned power. And that's not because the processing itself, in terms of exact amount of energy, is very different when you process in the cloud or on the device itself. But the cost from an energy perspective of transmitting the data to the cloud is very substantial. So that's the piece that you can really save on. And if you take, for example, a security camera, like you have in your home for your home security system, that it can be primarily used to determine if there's a person in that room or not. And to kind of transmit the picture of the room to let the cloud determine if there's a person in this picture, that can be, in the kilobytes, thousands of bytes. Whereas the information of whether there is someone there or not, that is a 1-bit information, 0 or 1. And so that, for me, that's the difference between data and information that is really critical to optimizing for power consumption, making as much of the determination as possible on the cloud, on the device itself, transmitting to the cloud only the information necessary to determine what happens there. So that's a big part of it.
So let's analyze the TI's philosophy around toolchain and support for developers. So what about your ecosystem tool strategy that would help developers bring edge AI into their connectivity solutions?
So our philosophy on tools is very simple in this case. We have really embraced the open source tools for edge AI. I think in general, edge AI came about at a time when more and more people, more and more companies were embracing open source tool chains. And we're definitely on that journey across our entire portfolio. But with edge AI, I think that we started there. And I think that's very powerful because these are solid tools. They were developed by the community. They're very fit for purpose. And okay, and then what's TI's job in that? So I see that we need to provide a framework around those tools to make it really easy for people to use it who are beginners. Because take a tool like PyTorch that we use, or a TVM compiler, fantastically powerful tools, but they're not very easy or intuitive to get started with. So this is why, on top of those tools, we provide a GUI-based tool called Edge AI Studio that takes you through the whole process of everything from data collection to model selection, optimization, validation, and deployment on the device itself in the end. That guides customers through that whole process in a very simple way. And allows them to sort of get a good handle on what using Edge AI is really about. Eventually, then, underneath there are those very powerful open source tools that then they can use in a command line setup as well to do their regressions and optimizations over time as they get more comfortable. The other aspect is, of course, optimization, right? Open source tools, they live from contributions. And so our contributions are to make sure that these open source tools support our devices optimally, and that we can get, the power consumption and the model sizes, et cetera, that are requested by the customers. And of course, validation, documentation, these things. So everything around, but really, like, the core of what we deliver is all open source.
Good. So as you know, machine learning, for example, is changing, is transforming different areas like car access and sensing, environmental sensing. So focusing on automotive field in particular. So what new possibilities do you see opening up? How might this create new business models or innovation opportunities?
Yeah, I think there's some very well established uses of edge AR, machine learning in cars today. Self-driving, primarily based on local processing.
The main
machine
one.
learning. Yeah. Motor faults is a big one, where we also have a significant contribution from TI. But then on the connectivity side of it, I think machine learning will primarily have a role in distance estimation for car access. There's certain scenarios there where we see that we can have good use of neural network in processing complex signals in Bluetooth channel sounding. And there's also in-cabin sensing, for example, who are in the seats, try to classify, because it's really important to understand, okay, is this a person, an adult, a child, a pet? And these are, anytime there's like complex analog input signals and you're looking to do a very distinct classification of what's going on, what's the event, that is where it really, machine learning thrives at the edge. And I think anytime there's a non-trivial problem to solve in inputs that are analog of nature, you will see that edge AI will play a role in it in most cases. So of course we need to draw the line, right? Because if you can do a simple FFT and draw like a clear threshold, okay, if it's above that, then X. If it's below that, then Y. Then edge AI has no role in that. Then traditional algorithms like FFTs will do a better job. But the world it's very rarely that simple. When you start looking at these analog inputs. And you can also extract more information from the same sensors than what we were used to getting. So I think this is also an area where we will see significant improvements. There's so many sensors in the car. And what can be learned is by no means fully used up. Okay, so that's.
Thank you. Great. So you mentioned motor faults, you mentioned FFT. So all of these are also important in terms of industrial automation. So switching to industrial, how can AI-driven predictive maintenance and sensor fusion improve efficiency, safety inside the factory lab?
Yeah, no, those are great kind of segues between the two. Predictive maintenance is really a staple for machine learning, as we talked about, right? And inputs like vibration and sound on factory floors, they've been used for many years to do predictive maintenance, for 100 years. The difference is it used to be done by some experienced people that knew these machines like it was their own babies. They walked around the factory floor. They would listen to them. They would feel them. Is it hot? Is it cold? Is it vibrating? And then they would say, this one needs to be serviced. And that's good, but they can't do that continuously. They can't do that at scale. And they can't do that, with the same precision that you can get with machine learning. So if you can, the training data for this largely exists, and this will be a significantly more accurate way of doing it. Like you take a small Bluetooth system on chip, combine it with a selection of sensors, and you can very accurately predict which parts of your machine park needs to be serviced very quickly. So it's I think this is a very, very powerful use for it.
So as you know, other systems are becoming intelligent networks, and I'm talking about TPMS, or tire pressure monitoring, and BMS, battery management system. So both are becoming intelligent networks that can make any decisions at the edge. So what's the biggest challenges in this regard in making sure that they are robust and reliable in automotive fields that are harsh automotive environments, and how do the requirements differ between this technology, TPMS and BMS?
No, in both cases, as you mentioned, the radio environment is challenging. With the tire, it's in a special situation because there is no way to pull a wire from a tire pressure monitor sensor, and so it's always been a radio requirement to get the information from inside the tire to the car ECU. So the difference now is that we're seeing this that this is now moving to Bluetooth, and the Bluetooth is a very robust algorithm. It is time slotted, so it can be very low power. It is at the same time, it has all the checks and balances on the inputs to make sure that you're actually getting the right data, and it's got the security features. And it has retransmissions to make sure that if you're unlucky and lose a packet here or there, you still actually get good measurements into the ECU. So I think Bluetooth is a good kind of just solves the problem in my mind with the TPMS. In BMS, it's definitely more challenging. That is an environment where a good portion of it is still consists of metal for good reason, right? You're trying to encapsulate the battery pack, and so in that scenario, you have to have some additional robustness in terms of just the link. But the other aspect is you have strict quality of service requirements. It's not okay that you don't get any data for a little bit. You need to make sure that you can consistently deliver good data, because this, from a time perspective, this is a much more sensitive safety application. So in that scenario, we have actually developed our own protocol, a proprietary protocol based off of our learnings over the past couple of decades on getting robustness into a protocol and being able to deliver a high amount of data with low latency reliably. So that they do differ a little bit in that scenario, but yeah, both of them are very, very solvable with wireless, but it's different requirements for sure.
Yeah, and what about in this case standardization? So how important is it this topic? I mean, when you are driving adoption these both technologies, so in different platform or vehicles. So are you seeing real progress in getting the industry aligned on one approach?
Yeah, no, it's interesting because you can sort of drive standardization, but in a way, sometimes it kind of just comes naturally. So for TPMS in particular, like the reason why everyone is now moving to Bluetooth for tire pressure monitoring solutions is primarily because the car access solutions incorporated Bluetooth first. So everyone wants to use their phone as a car key now. And the simplest way to do that is to add Bluetooth and a couple of other technologies potentially. And that means the infrastructure is already in the car. the Bluetooth is connected to the CAN is connected to ECU. So once you have that Bluetooth radio, potentially a couple of different places in the car, it's very natural to have the tires also talk to that. Big savings, right? So yeah, but in that case, the fact that you could solve TPMS with the same standard protocol as is being used for car access really enabled that transformation to happen very quickly, and kind of with a very large number of OEMs going in that same direction at the same time.
So in terms of, so we are talking about wireless connectivity, we are talking about AI, and when we are putting together this technology, for sure, it can open new possibilities, talking across different markets, automotive, industrial, and IoT. Let's focus on vehicle-to-vehicle, vehicle-to-infrastructure communication. What does that mean specifically for these technologies?
Yeah, I think those technologies, it's like a good companion to edge AI, especially because V2V and V2X is mostly about not communicating everything to the cloud and then back down again. You're making some local connections out in the real world, and then edge AI fits the kind of glove in hand with that, because that means that there is processing. You can have each vehicle determine, its own state, but also the state of the environment around it using local edge AI, and then communicating that directly with other vehicles or chargers or things that are around it. And it does, in both cases, kind of help remove the dependency on the cloud for the car to operate properly. So I think those are really, very complementary, very good partners in terms of technologies.
So, and I think that in this regard also a sort of standardization is useful. To define a standardized ecosystem for connected AI devices in this regard. So, how important are to make communication seamless across industry? So, do you see any partnership that would fit in this regard?
Yeah, I think the most important partnership to me is the partnership between sort of silicon vendors, tier ones that develop a lot of the electronics technology, the OEMs who make the cars, the tool vendors that make, for example, the car chargers or the TPMS tools for the mechanical shops. So everyone needs to kind of put their heads together to figure out how this in the end is going to drive a great user experience for the customer. No one understands everything about the system. So it's like it takes everyone getting together and deciding on some minimum set of standardization, I would say, that gets the industry to scale quickly. Many people can use the same technology and allows for real fast growth, but also leaves room to innovate and move faster than the standardization on new features. So it's a delicate balance. But for some of the key technologies here, TI has been instrumental in defining Bluetooth standard over many years. And now recently channel sounding in particular, which is the communication between the distance estimation between the phone and the car for car access. Having phone vendors now part of that ecosystem, and seeing those partnerships created between the phone manufacturers and the car manufacturers, which was not a given a few years ago. Yeah, it's really enabled a lot of new, interesting user experiences in the end that I think we'll see coming to fruition in new cars now and over the next few years.
Thank you, Peter. So just in conclusion, my last question for you, we have analyzed different topics around connectivity. So looking to the future, so what's your final comment about edge AI and wireless connectivity for the next generation in terms of automotive and industrial solutions? And so just which are your takeaways, at least 3, that you would like to leave to our listeners?
I think there's in terms of like connectivity for the next generation, combining with the AI at the edge. I think we have not seen, and I'm confident that I've not heard of, but thought about some of the biggest applications that we'll see for this. It will be enormous. And I think it's kind of similar to when, like almost 20 years ago, we released the first Bluetooth system on chip from TI, and it was the first in the world. At that point in time, I don't think we foresaw what this combination of standard Bluetooth radio plus processing would transform, the automotive car access industry or asset tracking. Just think about all the trackers we're surrounding us with now that are on Bluetooth. We didn't foresee that at all, none of it. And I'm confident we're in a similar situation now with this combination of connectivity and edge AI. And I'm just excited to see what comes next and be part of that. So in terms of key takeaways for me, I think it's important to remember edge AI can solve very well non-trivial classification issues. Much better than traditional algorithms, but yeah, it has to take some thinking to understand when it's going to be useful. But when it is useful, it's extremely powerful. And to remember that dedicated on-chip acceleration of neural network processing enables the processing to be done with really low latency and power to move more things from the cloud to the edge. Those are my key takeaways.
Thank you, Peder. Thanks a lot for sharing your insights. That's all for today's Embedded Edge. So stay tuned for our next conversation on technologies shaping the future of embedded system. Thank you, Peder. Have a good day.
Thank you, Maurizio.
This episode of Embedded Edge was brought to you by Texas Instruments, TI. Thank you very much, TI, for sponsoring us. If you want to learn more about TI solutions we have been talking about today, please check the links on the podcast page at eetimes.com or powerelectronicsnews.com or the TI homepage, ti.com. Thank you.
That brings us to the end of this episode. Stay tuned for more news and technical aspects about embedded systems design. If you are listening to this on the podcast page at eetimes.com or embedded.com, links to articles on topics we have discussed are shown on this page. Embedded Edge is brought to you by Aspen Core Media. The host is Maurizio Di Paolo Emilio, and the producer is James Eade.